What is up, everyone? It's Mr. Lang again, and in this video I'm going to show you the shifted form of a parabola. For this video you need your note sheet that I handed out in class. You also need a pencil, of course, and a calculator would be nice. Not totally necessary, it just speeds things up in parts. So if you're ready, let's get going here. Alright, on our note sheet, number 1, it says below is a graph of the quadratic function y equals x squared. This is a parabola we've seen a lot of. We know it has a vertex or turning point at 0, 0, which also is its minimum value. We know it opens upwards, and it's got this nice parabolic shape that we're pretty used to at this point. So in part A, it says use a table of values to graph y equals x squared minus 3 and then describe that shift. So what I'm going to do is break out my radical orange calculator here and graph it like it's asking me to. So I'm going to go to the y equals button. I'm going to put in x squared minus 3 and hit graph. And you can see this is a parabola. It looks like the same thing. The only thing that's different is that everything was shifted down 3 units. And honestly, this should be no surprise to you because back in Unit 2, we looked a lot at functions and moving them around and shifting them. And we know that if we put a minus 3 at the end, it's just going to move everything down 3. That's exactly what happens here. So listen, it says to use a table of values to graph this. I don't think we need it now that we remember the rule here. So I'm going to go back here and just take it point by point and move each point down 3. So I'm going to start with the vertex here, move 1, 2, 3. I'm going to do each of these points down 3, 1, 2, 3, and 3 here. And I'm going to move 1, 2, 3. And this would be over here. I'm going to draw on my parabola. And you should notice with these shifts, it doesn't change the shape of the parabola at all. Should look exactly the same. The only thing that changes is where it gets moved to. So this was my part A. Now that we remember this rule, the plus 2, what do we think that's going to do? Well, that's going to move it up 2. So, well, first of all, I forgot to describe the shift here. This is down 3. Alright, so now let's go to the plus 2. The plus 2 I'm going to do in red here. Plus 2, I'm just going to take every point from the original and move it up 2. So that would go there. This one I'm going to move up 2. And these I'm going to move up 2. Not the worst parabolas I've ever drawn, but definitely not the best. Alright, and this is my part B. So this would be up 2. And then in part C it says, what would the vertex be for y equals x squared minus 150? Well, we know this would be down 150, but what would the coordinates be? What would the vertex be? So it's looking for the xy coordinates. Well, the x wouldn't change. It would still be 0. But the minus 150 tells me it would be moved down to negative 150 in the y. So that would be our new vertex. Alright? So here's what I want you to do for number 2. I want you to pause this video and do part A just like we did. You actually use the calculator to do it. And then once you remember that rule, you can finish graphing it. So pause the video here and try number 2 on your own. When you're ready, unpause it and we can check our answers. Alright, your work's done. I know that because you unpaused it and you're not a cheater. So let's check our answers. With the x minus 4 in the parentheses being squared, that actually has the opposite effect. It moves it to the right 4. Hopefully you remember that from earlier in the year. So this is my part A, moved it to the right. The plus 3 on the inside moves it left 3, and we can see that over here. It got moved left 3. And then if it's x plus 19 quantity squared, that means the whole parabola is going to be moved 19 to the left, so the new vertex would be negative 19, 0. Listen, if you got any of those wrong, just check them with the calculator, go back. No big deal. All right, so let's get down to the important part of this video. Probably the most important part is the vertex form of a quadratic function. It's f of x equals a times the quantity x minus h squared plus k. And there's a lot of letters here. The a is the same a as an ax squared plus bx plus c. It's that same leading coefficient. The x means the same thing too. The h and k stand for different numbers. It actually, if you take the coordinate h comma k, that is the vertex, which is really cool because it's kind of like, you know, with lines, the general form is y equals mx plus b. We like the line, that form, because the m is the slope and the b is the y-intercept. We can graph it if we have it in that form. It's very similar to this. If we put quadratic functions in this form, then we know exactly where the vertex is. Makes it really easy to shift things around. So we're going to do some examples now that we know this. All right, next page, 3a. It says the parabola is y equals x squared minus 6x plus 10, which is the general y equals ax squared plus bx plus c form. And this one in the vertex form are actually the same thing. And they want us to prove it. Well, they don't look anything alike. But we're going to leave this one alone. And what I'm going to do is simplify this. So I'm going to rewrite it here. And what I'm going to do is just kind of look at this part right here. This is a binomial being squared. And we know what to do with binomials being squared. We make our window. And I'm going to put an x minus 3 here. I'm going to put an x minus 3 here and do it out. X times x is x squared. We're going to have a minus 3x here, a minus 3x here, and negative 3 times negative 3 is positive 9. So when I add this together, I get x squared minus 6x plus 9. So what I'm going to do is, get that out of there, I'm going to substitute that in for the x minus 3 squared, since they're the same thing. And then I'm not going to forget to put that plus 1 in at the end. All right, and then finally, if I combine like terms, I get x squared minus 6x, and then the 9 plus 1 gives me a 10. And check this out. This thing is the same thing as this thing. So they actually are the same thing. But what's cool about this one is it tells me where the vertex is. The vertex is going to be at positive 3, 1. So that's my answer to B. The new vertex, or actually just the vertex, is 3 because it starts at negative, and then 1. So it's always the opposite for what's inside, but the end is the same. That's why the vertex form is so good. All right, moving on to number 4. Here again is the quadratic function f of x equals x squared. Use it to graph the following two functions and label. All right, so now we've got g of x. So this is f of x, the one that's graphed. We're going to do g of x, and that's x minus 4 squared minus 3. Well, that minus 4 tells us we're going to move to the right 4. The minus 3 here means we're going to move down 3. So what I'm going to do is just take it point by point like we did before, and I'm going to move to the right 4 and down 3. Here's my vertex. To the right 4 and down 3. To the right 4 and down 3. To the right 4, down 3. To the right 4 and down 3. And there is my part A because it wants us to label. Part B I'll do in red. This would be the plus 4 on the inside means I'm going left 4 this time. And the plus 2 on the outside means I'm going up 2. So I'm going to start from the original one again, and I'm going to go to the left 4 and up 2. Left 4 and up 2. Same thing here. I'm going to go to the left 4 and up 2 for this one. I'm going to go left 4 and up 2 here. And that's it. All right, so that's the vertex form. Again, it's kind of like our y equals mx plus b, but for parabolas. So let's get to the SIA. The SIA questions, just like last time, are on a separate document. Do those questions, do the quiz. You're all good to go. Thanks for listening.